In this video, we're going to look at our factoring method using difference of squares. We've talked about our perfect squares and what a perfect square is, and we've listed out the first 16. These really should be things that in your brain, when you hear 144, you should think, oh, that's a perfect square. We use our perfect squares enough that knowing and recognizing them can save you a lot of time and energy. So what we're going to look at today is this method difference of squares. So first of all, when are we going to use it? We're going to use it when you have a binomial, so two terms, where they're both perfect squares. So from this list up here, and it's subtraction. So it's going to look like this, a squared minus b squared. And remember what we did to get this? We took this and multiplied it. Our middle terms are a zero pair, so they subtract out, leaving us with just the a squared minus b squared. But we're going to use it backwards. We're not going to use it to multiply. We're going to use it to factor. So we're going to take anything that's of this form, two terms, subtraction, both perfect squares, and we're going to do our formula. Our steps. You're going to determine the values of a and b. You're going to do that by taking the square root. And again, we'll use these values up here. And then we use the formula to factor. So let's look at our example 1. First, I need to make sure it's two terms, it's subtraction, and these are both perfect squares. So it is, in fact, difference of squares. So the first thing I'm going to do is determine my values for a and b. So a, I'm going to do the square root of x squared, which is x, and b, I'm going to do the square root of 49, which is 7. Now here's what my formula tells me. It tells me a squared minus b squared equals a plus b times a minus b. So this part here is my a squared minus b squared. I'm going to use this and this to factor without showing any work. So in place of a, I'm going to put x. In place of b, I'm going to put 7. And that's it. Now I could go through the process of doing a times c, adding to b, which is 0, filling in the box, pulling out the GCF, but my formula allows me to do it just a little bit easier here. Well, let's look at example 2. So again, subtraction, two terms, perfect square, perfect square. If you're not sure if it's a perfect square, look to this list. Now, obviously, if it's bigger than 256, I'll have to actually do some work. But on this list, I see the 9, and I see the 100 right there. So the square root of 9 is 3. The square root of 100 is 10. And the square root of y squared is just y. So I'm going to find my a and b. My a, square root of 9 is 3. Square root of y squared is y. My b, the square root of 100 is 10. So I'm going to do a plus b and a minus b. I don't put a, I put 3y because that's what my a is equal to. And that's it. Example 3. Even when they're complicated looking, this one looks really super ugly. It's two terms, it's subtraction, perfect square 4, perfect square 81. Again, if you look up here, square root of 4 is 2, square root of 81 is 9. So to find my a, I'm going to do the square root of this. Square root of 4 is 2, square root of x squared is x. To find my b, I'm going to look to this. Square root of 81 is 9. Square root of y squared is y. And then a plus b, a minus b. And that's it. Last one, 25x squared minus 16. So again, two terms, subtraction, both perfect squares. you look at my list, square root of 25 is 5, square root of 36 is 6. Sorry, 16, not 36. Square root of 16 is 4. All right, so to find my a, I do the square root of that. Square root of 25 is 5. Square root of x squared is x. To find my b, I do the square root of that, which is 4. And then a plus b, a minus b. And that's it. Now I do want to make a note here. It has to be difference of squares. It has to be subtraction. If it's a sum, even if they're both perfect squares, not factorable. You can't factor this. It is prime. The only things that go into x squared plus 16 is x squared plus 16 and 1. So this one cannot be factored.